All right, this is going to be your entry task. It is quiz review, so I want to make sure that you are ready to go for your quiz that is happening today. This will be the only practice problem. So take about 5 to 10 minutes to practice this. Please pause the video so that the students can take this practice quiz or question, and then in about 10 minutes we'll go over it. All right, about this time, students should have had plenty of time to at least attempt this problem. I'll try and go slowly so that you can follow along, so that you can use these notes on your quiz, because it is an open note quiz. The first thing I see when I look at this problem is I see that the denominators are not the same. So I need to make sure that the bottoms of these fractions are exactly the same so that I can start adding them together. So I'm going to take the 3b plus 12 and multiply it over here, 3b plus 12 on the left side. And then I also have to multiply this other bottom by the 2b so that they have the same, because right now this fraction is missing the 2b. So multiply this side by 2b. And what I do on the bottom I have to do on the top. And I'm going to just wrap everything in parentheses. So what I do on the bottom, I have to do also on the top. All right, at this stage, I notice that I now have common denominators. So I've got the 3b plus 12 times 2b and the 3b plus 12 times the 2b. And I need to distribute the numbers to each other. So the 2 goes to the 3b, the 2 goes to the 3b, and the 2 also goes to the 12. So let's do that downstairs in blue. So 2 times 3b is 6b, and 2 times 12 is 24. Minus, I'm bringing down this minus sign right there. I'll even do it, I'll draw it out in red so that the minus sign is carrying down from there. But I also have to do this 2b to the 2 and the 2b to the b. So that's 2b squared. And 2b times 2 is 4b. Now, I have a common denominator. My common denominator is 3b plus 12 times 2b. And at this stage, notice that I have that minus sign. I have to distribute that negative to both of these terms. So we've done this earlier in the year, so I'm going to distribute that negative to this, distribute that negative to that, and I'm going to rewrite it down below. So we still have a common denominator of 3b plus 12 times 2b, and I still have that 6b, and I still have the 24, and now I'm doing the distribution, so negative times 2b squared, so minus 2b squared, and the negative distributing to the 4b, so negative 4b. Now, I'm going to combine like terms because I see that I have a 6b and a 4b, and I think that maybe I can rewrite it in standard form. So let's rewrite it. So negative 2b squared, so I covered that one. The 6b minus 4b is negative 2, it's going to be a positive 2b, and then plus 24. So it looks like I covered all of those, and then it's all divided by 3b plus 12 times 2b. Now, I got to be really careful, and because at this stage in this problem, I'm thinking, oh, can I factor the numerator? So I'm going to try factoring it, and I'm going to try factoring it off to the side. Let's do this in black. So if I try factoring, I try negative 2b squared, 24, 2b. So what two things multiply to negative 48? So I'm going to try and add to 2b. So I'm going to try negative 1 and 48. No. Negative 2 and 24. No. Try negative 3 and 16. Divided by 4. Negative 4 and 12. No. 48 divided by 5. No, that doesn't work. Divided by 6. Oh, negative 6 and 8. That will work. That will work. So negative 6b and 8b. So my common factors here are, it looks like negative 2b. And so that makes that just a b. And that's got to be a 8. So 8 times 3 is 24. Does that work out? Yeah, that works out. So this numerator, the top of this fraction, can actually become, the top of this fraction can become this negative 2b plus 8 times b plus 3. I'm just getting those from this right here. And then my denominator is still 3b plus 12 times 2b. And no matter how I slice it, I can't simplify this anymore. I've really kind of put my best effort in there. This problem is probably a little bit more difficult than what you're going to see on your quiz. But I need to be sure that I know my exclusions. So I know for a fact that b cannot be 0, because if b is 0, then 2b is 0, so this whole bottom is 0. And I notice that the 3b plus 12, that also can't be 0, so I'll do that. 3b plus 12 can't be 0, and if I start solving this, so 3b can't be negative 12, divide by 3, divide by 3. Oh, b can't be negative 4. So b can't be negative 4, b can't be 0, and this is as simple as we can get it right now. We probably could factor out a 2 and cancel out a 2, but for now, I want you to have the opportunity to do your quiz. So when you are done with your quiz, it's actually a quiz retake, we want students to be able to solve more complicated radical, by radical I mean square root, cube root, different types of root, solve more complicated equations and understanding the possibility that there might be a non-valid solution. So you should be able to solve an equation involving radicals, that's the square root thing, and use factoring and multiplication to solve. You should be able to substitute your answer back into the equation to check to make sure that it's valid. So we just reviewed for the quiz. We're going to give you an opportunity for a quiz. When you're done with your quiz retake, it's actually a retake, so not everybody has to take it. If you don't want to retake it, you can retake it after school when I get back. But if you don't feel comfortable taking it today, then don't. But you do need to be working on practicing more of this stuff if you don't. So there will be something for you to do, whether or not you take your quiz today. I'm going to give you some more notes on this video once the quiz retake is done, or when most people are done, and then there will be time for lesson 29 practice. For homework tonight, I want you to practice several problems. If you go all of midwinter break and don't practice these problems, it's going to be really difficult when you come back, because we're going to have to quiz out of this unit pretty quickly once we get back from midwinter break. Just so you know, keep that on your radar. So we're about to take the quiz retake if you plan on doing it. If you want to have me grade it, you must complete quiz corrections. When you turn them in, quiz corrections involve redoing the missed problem and writing a sentence about them. I need you to attach your quiz corrections to your quiz retake. That means that your quiz retake is on top and your quiz corrections are behind it. I need you to do that. If you don't have them today, you can still take the quiz retake, but I won't grade it until I have those quiz corrections. If you don't feel comfortable taking it today, maybe you're not ready, maybe you just need more time, there are going to be other opportunities, but they're going to be after school. So if you don't take it in class today, you're going to have to wait until the unit test. So in order to retake the quiz, you must have quiz corrections in order to retake this quiz. All right, please make sure that your tables are in rows, that your cell phone is away, that your desk is cleared. You may use a calculator. A calculator is okay. This is an open note quiz, but you should not have your cell phone out whatsoever. When you are done, you need to attach with a staple your quiz corrections. You can have as much time as you would like, but I am going to only set aside 30 minutes. After 30 minutes, please continue to play this video. So I recommend pausing the video at this time and give the students about 30 minutes to take this quiz. If students need more time, please provide them with as much time as they need in this class period. If they don't finish in this class period, they'll turn in what they have, but we're only going to allocate about 30 minutes to this quiz. Please pause the video now and restart it when you're done. All right, please distribute the lesson 29 packet to students, and I'm going to ask that you show the video because I'm going to show example 1. I'm gonna go over exercises 1 and 2 later in the video, but I want to do example 1 first. I'm gonna ask that as we do this, please be persistent and seek more. As you attempt these problems, there are some challenging problems, but I really want you to spend a good amount of time practicing them, or at least attempting them. All right, so this is example 1. We'll go over this quickly, and then I'll give you a little bit more work time. The task for example 1 is to solve this equation. Now, we've talked about what to do in the event that I've got a square root, but here I have x plus the square root of x. And if I start squaring this, I'm not going to like the result. So I need to get the square root all by itself. I need to get this square root all by itself. So I'm going to subtract x from both sides of the equal sign. And in this way, I'm going to get 6 minus x equals the square root of x. So I just subtracted the x from both sides. Moving on, I now am going to try and get rid of this square root of x. And the way that we get rid of square roots is by squaring both sides. So I'm going to do this in blue. I'm going to square both sides of this equal sign. Now we can square both sides. So long as we're doing the same action to both sides, it's okay. On the right-hand side, I'm left with x because the square cancels out the square root, and I'm left with the stuff inside, so the stuff inside is just x. And on the left side, I have 6 minus x squared. Now remember, a square is the stuff multiplied by itself. So really, this is 6 minus x times 6 minus x. And I'm going to have to bust out a little bit of polynomial multiplication to finish this problem. So 6, and then negative x, and then 6, and then negative x. So 6 times 6, 36. 6 times negative x, negative 6x. 6 times negative x is negative 6x. And negative x times negative x is positive x squared. So if I add the diagonals, so I got 36. That's a minus. It's a negative 12x plus x squared. Oh, so I can use that in there. So I'm just going to kind of rewrite it in a different way. X squared minus 12x plus 36 equals x. So I just took this 6 minus x times 6 minus x, I multiplied it, and I rewrote it down below. So I'm just expanding it through multiplication. Well, now I'm going to subtract the x from both sides. So I've got x squared minus 13x, because I'm combining like terms, plus 36 equals 0. So when I have this, we know how to do this. I gotta factor this. All I'm doing from here is factoring. I'm gonna factor this. So I've got x squared 36. The diagonal has to add to negative 13x. The diagonal multiplies to 36x squared. So what two things multiply to positive 36 squared? That make a negative. So I've got negative 1 and negative 36. I've got negative 2 and negative 18. I've got negative 3 and negative 12. I've got negative 4 and negative 9. Oh my gosh, that adds up to negative 13. So I've got negative 4x and negative 9x. And I'm going to factor. All I'm doing here is factoring. Common factor of x. This is a negative 9. This has got to be negative 4. And this has got to be x. So my factors are x minus 9 times x minus 4, that equals 0. Oh, what makes this 0? X is 9, because when x is 9, that's a 0, and 0 times stuff is 0. And x is also 4. Now I'd recommend plugging these back in and checking that those two answers actually do what they say they'll do. For now, we'll go ahead and accept that. But actually, why don't we do that? So let's try plugging this back in. Here's our check. Here's our check. Here's our check. We're going to check that 4 works. And maybe it doesn't. Who knows? So we're saying, does 6 equal 4 plus the square root of 4? I don't know. So does 6 equal 4 plus 2? Yeah, that works. So 4 is valid. And we're going to check 9. Does 9 work? So is 6 equal to 9 plus the square root of 9? Well, 6, so we're saying is that, so is 9 an answer? 9 plus the square root of 9 is 3. Doesn't look like it. 9, so that's 12. No, so not, the 9 is not valid. So just a quick overview of what we did is step 1, we got the square root alone. We got the square root alone, and then we squared both sides, but because it's a binomial, I have to multiply them out. So I multiplied them out. I now have a polynomial on this side, and I wanted to get the x's all together. I wanted to get all the same variables together. And then I realized, oh, I can factor this. So I factored this polynomial, and I got this, and I got 2 answers. So I got 9, and I got 4. When I checked them back into the original equation, it looked like 4 works, but 9 doesn't work. So that doesn't work. All right, I want you to spend about 10 to 15 minutes working on exercises 2, 3, and 4. We're going to go over these problems later in this video, but please pause the video. Actually, I'm going to say more like 20 minutes, since these sometimes can take a long time. So between 15 and 20 minutes, please spend about 15 and 20 minutes. Pause the video, work on it for 15, 20 minutes, and then play the video again so that you can understand. I'm going to go over some of these problems later in the video. I really want you to do your best work. I know some of these are challenging, but please be persistent and seek more as you attempt these problems. When we come back, I'll go over them. I promise. This is sometimes challenging. This is a challenging standard, and the more you practice, the better you're going to get at it. So please pause the video now. All right, so here we're going to try exercise 1. Remember that when we're doing these problems, we want to make sure that we're getting the square root by itself. We don't want this 2 in front of it, and we definitely don't want that plus 1. So we're going to move both of those things over using some properties of algebra to do that. So the first thing we're going to do is subtract the 1 from both sides. So I've got 3x minus 1 equals 2 times the square root of x, and we're trying again to get this square root of x all by itself. So the next thing I want to do is get rid of this 2. So if it's 2 times the square root of x, the way to get rid of multiply is by dividing by 2. So everything has got to get divided by 2. And those cancel out, and I'm just left on the right side with the square root of x. And on the right side, we can leave it as a fraction, or we can share that 2 with both things. So I'm going to do that. I'm going to do 1.5, because 3 divided by 2 is 1.5. 1.5x minus 1 divided by 2 is a half. Okay, to get rid of the square root, remember that we square both sides, so we're going to square both sides, and we actually have to write the left-hand side as 1.5x minus 5 times 1.5x, minus 0.5, minus 0.5. Maybe I'll put 0.5, just so that I remember it's a 0.5, equals x. All right, and again, I have to multiply those factors out. So 1.5x minus 0.5, 1.5x minus 0.5. So I've got 1.5 times 1.5 is 2.25. So 2.25x squared. 0.5 times negative negative 0.5 times 1.5 is negative 0.75x, and that's also going to be the same thing, negative 0.75x, and then 0.5 times 0.5 is 0.25, so that's going to be 2.25 from this diagonal, x squared plus minus 0.75 plus 0.75. So that's going to be negative 1.5x plus 0.25 equals x. Equals x. That should be x. My bad. Equals x, because I'm just bringing the x down from there. All right? And subtract x from both sides. Combine like terms, so 2.25 x squared minus 2.5 x plus 0.25 equals 0. At this point, I would recommend using the quadratic formula to solve these problems, which would be my A is 2.25, my B is negative 2.5, and my C is 0.25. And just using the quadratic formula, so negative 2.5 plus or minus the square root of b squared, so negative 2.5 squared minus 4 times 2.25 a times c, 0.25. All of that over 2a. I know it's a lot of work, but I got 2.5 plus or minus, and I'm going to do the parentheses, 2.5 squared minus 4 times 2.25 times 0.25 in the calculator. I get 4 underneath here. So that's kind of nice that I get some things.
Can I have your...
As I was saying, it's kind of nice to get such a simple answer. And 2.25 times 2 is going to be 4.5. And we get 2 answers. Sorry, it's kind of hard to see that. So 2.5, the square root of 4 is 2 over 4.5. So I get the 2 answers, 2.5 plus 2 over 4.5, and 2.5 minus 2 over 4.5. 2.5 plus 2. So that ends up being 1. And then this is 0.5 divided by 4.5 is 0.1111 repeating. Yeah, so we get 2 answers, and we should probably check those out. This was a really challenging problem, but that's how we do it, unfortunately. Let's try another one, and hopefully it'll come out a little bit more pretty for us. So this is going to be exercise 2. I'm hoping this one turns out a little bit nicer than the previous one did. But again, we want to get those x's all by themselves. So the first thing that I want to start doing is moving that x to the other side. So I got 3 plus x, or x plus 3, equals 4 times the square root of x. So maybe we'll do, maybe it'll come out prettier if I do it a little differently. Divide both sides by 4. So 1/4 times x plus 3 is equal to the square root of x. So I square both sides, square this, and I square that. Maybe it's better if I square it like this, where I do 1/4 squared times x plus 3 squared equals x. That might make it a little bit nicer, actually. All right, so I got 1/16, or excuse me, let me diverge for a second. Let's do 1/4, so it's 1 squared over 4 squared times x plus 3 times x plus 3 equals x. So that's 1/16 times x squared plus 6x plus 9 equals x. And then we can start subtracting the x out. So minus x, minus x. But this doesn't come out pretty anymore. Let's just pause here. So 1/16 times x plus, so x squared plus 6x plus 9 minus x equals 0. Yeah, these aren't coming out very pretty, but so long as you can start doing this, we should be fine. All right, my hope is that these come out a little bit nicer. I think this is actually quite friendly. I'm sorry this is so bizarre. These are quite challenging problems. Right now when I look at this, I see that the square root of x plus 5 equals x minus 1, and I already have this square root finished, so I'm just going to start by squaring. So square both sides, square both sides. I get x plus 5 equals x minus 1 times x minus 1. And I could do a quick box, x minus 1, so x squared, negative 1x. This is also negative 1x, and this is positive 1, so the left side becomes x squared minus 2x plus 1. So x plus 5 equals that. And I'm going to move all of the terms over. So I'm going to subtract 5. So then I got x equals x squared minus 2x minus 4. And then subtract x. So subtract x. And I've got 0 equals x squared minus 3x minus 4. And this is much easier to solve than the previous two because I don't have all these fractions and decimals all around. And even though they were messy, they were doable on the previous. So x squared, you got our negative 4, negative 3x. And all I'm doing here is factoring. So I need two numbers that add to negative 3x and multiply to negative 4. So I know that to be 1x and 4x, and this is actually quite, negative 4x, so this is actually quite friendly, 1 and x. So this factors out to be x minus 4 times x plus 1, equals 0. So I get two answers, x equals 4 and x equals -1. So now I do gotta check them both. I'm gonna check them both. So I'm gonna say, is the square root for x equals 4? If I check x equals 4, is this a solution? So the square root of 4 plus 5, is that equal to 4 minus 1? All I'm doing is substituting 4 into this x, both x values, and I've got to put them into both. So this is the square root of 9, is that equal to 4 minus 1? 4 minus 1 is 3, and 3 is definitely equal to 3, so this is valid. We checked it. Let's check x equals -1. So the square root of -1 plus 5, is that equal to -1 minus 1? It's unlikely, because that's -2, and I know that square roots will never be -2, but we'll give it a shot. 2 is not equal to -2, so this is not valid. This -1 answer, it might be a solution when we solve it, but it's an extraneous solution. All right, last but not least, is this guy. Chances are you've checked out by this point because maybe these problems are really challenging. I don't want to have to factor, so I'm actually on this guy going to move the 2 root x minus 8 to the other side of the equal sign. So I've got 3x plus 7, so the square root of that, equaling 2 times the square root of x minus 8. And I'm going to square both sides. So I got 3x plus 7 on this side, and I've got 2 squared times x minus 8. I get the 2 squared from the 2 times the 2 squared, and then the square root of 8. X minus 8 squared is x minus 8. Okay, so this is 4 times x minus 8, and then 3x plus 7. Try distributing, so 4x minus 32, 7, 3x plus 7. So then minus 3x. There's lots of ways to approach this. So 7 equals x minus 32 plus 32 plus 32. 7 plus 32 is 39. So we're going to try x equals 39. And I'm gonna quickly do a quick check here. So the square root of 3 times 39, this is kind of gross, plus 7, minus 2 times the square root of 39. I don't like that. 39 minus 8. So let's try it. Hopefully that's gonna be 0. Maybe it's 0, maybe it's not. So 3 times 39 plus 7. That's the square root of 124. This better be square root 31. I really don't like this. So the square root of 124 is 2 root 31 minus 2 root 31, and that equals 0, so this is a valid solution. All right, at this stage, I think this video is getting way too long, so I'm just going to ask that you attempt these problems, and we're going to try them after spring break. I really appreciate your focus and participation today. Please do answer this question in your notebook. I really am curious to think what you think. What is the difference between these two problems here? Just quickly take a look at them. Maybe you'll have a really solid answer. Maybe you're just going to kind of guess, but I do want you to attempt these problems. Thank you so much for your work today. I want you to try as many problems as you can, and if you can't get it, that's okay. We're gonna revamp this whole lesson on square roots and radical functions after midwinter break. Thank you so very much. So between now and the end of class, you'll answer this reflection question and work on lesson 29.